Okay, let us see how to solve review exercises on regular polygon. The first one, it is a true-false question, and A says if a polygon is equiangular, then it is equilateral. This is false. We can take example rectangle. Rectangle, you know, each angle are equal, so it is equiangular, but it is not equilateral. Equiangular means every angle must be equal. So rectangle, that it satisfies that condition, but it's not equilateral. Only opposite sides are equal in case of rectangle. So that's false. B, equiangular hexagons are regular. Again, this is false. There are hexagons which are equiangular, but they are not regular. To be regular, it must be equiangular and equilateral. What does it mean? Every sides must be equal and every angles must be equal to say it is regular. So therefore, there are hexagons which are equiangular but not regular. So this is false. And when you go to C, all symmetric plane figures are polygons. That is false again, because we can consider a circle. A circle, it's a plane figure. At the same time, it has many or infinite number of line of symmetry it has, but it's not a polygon. To be a polygon, it should be n-sided figure. It should have, but a circle is simply complete curve or path. That is false. When you go to D, if a polygon is inscribed in a circle, then the polygon is regular, it says. Again, this is false, because there are polygons which can be inscribed in a circle, but they are not regular. Okay, what means an inscribed polygon? You know, completely it must be inside the circle and all the vertex must be on the circle. That's the definition of inscribed polygon. This time what we can conclude, the opposite angles are supplementary. If it is inscribed, that means these two angles add up and give you 180, and the same thing, the other opposite sides should be added and give you 180. But we cannot, especially for the quadrilateral, if it is inscribed. But inscribed polygon means simply the polygon must be completely in the circle, and then all the vertex lies on the circle. That's the definition. It doesn't mean necessarily it's a regular. When you go to E, fixing the radius of a polygon inscribed in a circle, increasing the number of sides of a polygon increases the length of the apothegm. That is true. This is the E is true. What does it mean? Imagine two circles. Okay, let's take it to the next page and let us see it. Let us have two circles, and here let's inscribe a triangle, regular triangle, imagine. Therefore the center will be here, and this is a radius, this is a radius, so the apothegm will be the distance from the center to the opposite vertex. But if the number of side of a polygon increases, imagine it is regular polygon again, I'm increasing the number of side, we cannot be sure like how many it is. So when we increase the number of sides, you know, still this is a radius, the apothegm length will increase, because the triangle gets narrower, and then the length will be here, the triangle will be flatter, so that the distance from the vertex to the side length will be smaller, so the apothegm increases. As the number of sides of regular polygon inside the circle increases, that means the apothegm will increase. That is true. And when you go to F, okay, what does F says? If a regular polygon of n side has every line of symmetry passing through the vertex, then n is even, it says. Actually, this is false. We can see here are polygons which are regular, all of them. As you see, the first one is a triangle, 3 sides. That means odd number of sides. So each line of symmetry passes through the vertex whenever it's odd. But if it is not odd, for example, look at the square, the line of symmetry passes through the opposite vertices, and at the same time at the center of like the side lengths. But look at again here, it's in pentagon, all the line of symmetry passing through the vertices. Therefore, if all the line of symmetry passes through the vertex, that means the given polygon is not even number of side, it must be odd number of side. These are the answers for the true false. When you go to the next part, the first one, it says actually all of them. The second question, it says find the marked angles. Here our marked angle is x. We are looking for x. First of all, let's get this angle. You know, it's supplementary here. They are supplementary. That means 180 together. So from 180, when we subtract 125, it will be 55. Again, the same thing here. When you subtract from 180, 64, because this is a straight angle again. When you subtract 64, it's going to be 116. And again here, the same thing. It must be 30 degree. Therefore, I have to add these three angle from then the total angle is, you know, 360, because it's a four-side figure. 360 the total angle should be. Let's represent by different color. This is 360 the total angle. Here the total angle, it is 1 2 3 4 5 6 sides, so 720. How do you know the sum of the total angle of a polygon? You know the formula, n minus 2 times 180. For example, here there are 6 angles, means it is a 6-side figure. As you see, we can count. So the total number of angles will be, plug 6 here. 6 minus 2 will be 4. 4 times 180 will be 720. And here it will be 540. The same process. It's 5-side figure. It's a pentagon. Therefore, now to get x in the beginning here, to get this x, first I have to get this angle. Okay, let's make it question mark. To get the question mark, first I have to add each of the angle here. What are they? So 100, let's add the angles. 116, 55, 30. When we add 11, 1, 0, 1, 201. Okay, 201 means if it is 200, 163 remain, but 159. So this angle is 159. This angle is 159. So what the remaining angle? X is the exterior angle. You know, the interior and the exterior angle add up and give you 180 degree. So this is 159 means this is the remaining angle must be 21 degree. So x is equal to 21 here. The second one, B, I have to add all of the angles. That means how many x are there? 4x plus 4x, 4x plus 4x. How many 4x's are there? 4. And then plus 3x plus x. Total number of angles are 6. When you add it, 8, 12, 16, 19 plus 1, 20x, which is 720. So divided by 20 both sides. So x is equal to, we can cut the 0 here, and 36. So x will be 36. The last one here, again, let's get supplementary angle, P. It must be from 180, subtract 81. That's going to be 99. And here also the same thing, I have to subtract from 180, 68. When we subtract 68, it will be 112. And now to get R remain, I have to add all the angles. 1, 2, 3, 4 angles I will add, and then from 540 I will subtract it. So 112 and 99, and then 165 and 110. Let's add it. When you add 11 and 5 will be 16. We have 1, 2 and 9, 11 plus 6, 17 plus 1, 18. I would have 1 here, 1 and 1, 2, 3, 4, 480. 486. Therefore, what is R? R is remaining. R is from 540. Let's take away 486. That is 40 and 14. So it will be 54. Obviously, you can subtract and check. Therefore, here P is 99, and this one is Q, which is 112, and R here it is 54. This is the way how we can do the first part. I'll be back with the remaining question in the second video.